Here's an example of using MATLAB Coder to generate a MEX file for the purpose of acceleration. Here we have an algorithm that is using DCT-based image compression and decompression. It's going to go through and it's going to take a look at our image in 8x8 chunks. From there, instead of our for loop, we're going to go through all the three colors, R, G, and B, and we're going to loop through the X and Y coordinates of our image. Like I said, we'll construct 8x8 blocks and we'll apply DCT to that in order to compress our algorithm. Once we run DCT2 on it, we're going to take a look at our output, and for any values that's less than 1, we're going to essentially throw away the extra DCT coefficients by making them zeros. Once we've done that, we'll go ahead and immediately decompress the image so we can see it on the screen. Here's our baseline image. So we're running our DCT compression.m file right now. On the left is our input video stream. We're going to process 20 frames of that. The image is 240 by 320 pixels. And on the right portion is our compressed and then decompressed image. So you can see that it looks very similar to before. Our original algorithm took about 25 seconds. We're going to use this as a baseline to compare other acceleration methods. In the second case, there's before you generate a MEX file, there are a number of different acceleration strategies you can employ, such as pre-allocation, vectorization, using system objects, using parallel computing toolbox. So for this demo, I'm going to show you the use of system objects. So this is essentially the same DCT compression algorithm that I just showed you before, but instead of using DCT2 and also IDCT2, I'm going to go ahead and use video.dct2d and video.idct2d system objects. The rest of the algorithm is essentially the same thing. And in the second case, using system objects, it took about 5.5 seconds, so we see acceleration of 4.5 seconds. Having done that, we can go ahead and create a MEX file and see how that works. So here we have the MATLAB Coder app, and right away we see that there may be an issue with code generation readiness. Opening the code generation readiness report, we see that there are two unsupported MATLAB function calls, idct2 and also dct2. If we click on each of these, we can rectify it. So while idct2 is not supported, we can use the one-dimensional idct in order to generate code for it. And I'll do the same thing. Over here, DCT2 is not supported, but we can use DCT, just the regular DCT. Having addressed that, let's take a look. This MATLAB Coder project was pre-built, so we brought in our DCT compression, and we're just going to go ahead and build the MEX file. So that's done. Coming back, we'll go ahead and run the MEX file version of our original baseline algorithm. And that was very fast. It only took about 0.7 seconds, so that's already a 35 times speed up compared to our original algorithm. But finally, combining techniques, we can take our system objects version of the algorithm and then create a MEX file for it. So here we have no such code readiness issues, so go ahead and just build the MEX file. Taking the system objects version of our algorithm and compiling into a MEX file, we see an even faster result. It took about 0.37 seconds, and that's about a 60 times speed up compared to our original algorithm. So using a variety of different acceleration strategies, in this case using system objects and also MATLAB Coder, we can speed up the rate of our original MATLAB algorithm.